to their seats?
Test. Anybody hear me?
Top up your coffee. Okay, I believe, although I'm not 100% certain, that this is going to be an NJ Cola first. Mark Amler was going to be here in person today, but because of all the heavy rains, his travel from Connecticut, he was concerned with flooding and that, and we have to respect that. So Mark is going to be speaking to us via Zoom. So this will be interesting. So I'm gonna turn the virtual microphone over to Mark.
Hello. Hopefully this is pretty seamless. Seems like it should be. So again, my apologies for not being able to be there. My name is Mark. I have a company, Pristine Waters. Primarily, we dredge ponds and lakes throughout New England and the northern part of the Mid-Atlantic. The reason why I couldn't be here, I don't know what it was like down in New Jersey, but this was the dam on the lake I live on. So that dam is probably about 30 feet high. And right now it's just a river. So we got an awful lot of rain up here. In any event. So Pristine Waters, my company, a little bit about me and about the company. We started in 2014. It really ramped up in 2016. We're based out of southwestern Connecticut. We've completed, I would say, well over 100 dredging projects throughout Connecticut, New York, New Jersey, Massachusetts, and Rhode Island. We've pumped, again, well over 100,000 cubic yards of sediment in the nearly 10 years we've been doing this. We started with diver-assisted suction dredging. I don't know if any of the folks there were at a meeting back in 2000, maybe 18 or 19, but I was actually in attendance at that meeting, and we talked a little bit about diver-assisted suction dredging. I'll go through that again today briefly. Since that time, we've really moved more into the direction of small to mid-scale hydraulic dredging, and I'll explain what the differences are. We also offer consulting services, sediment mapping services, and invasive aquatic plant removal. We've done a wide range of dredging work, from jobs as small as 100 cubic yards up to 13,000 cubic yards, which was actually done in New Jersey in West Long Branch as a subcontractor for a municipal job about a year and a half ago. We currently own 2 horizontal auger hydraulic dredges, suction dredge for the diver dredging, and I mean countless pumps, barges, and support equipment pieces. One of the first things that people ask when they call to inquire about dredging is how expensive it is that service going to be, and ultimately the answer is always the same thing, which is that we cannot possibly tell you without information, and generally speaking, without seeing the body of water we're being asked to dredge. Some of the components that go into determining what type of dredging is the proper methodology comes down to things like, what type of sediment are we talking about? Is it sand, or is it organic material, decaying plant matter, leaves, algae, so on and so forth? Other things that come up in this process is the sediment tainted. That will change the disposal cost And again, the methodology by which we dredge it, we generally don't send our divers into toxic environments for obvious reasons. In situations like that, we would steer you towards hydraulic dredging. Other questions are things like, how far do we have to move the sediment once it comes out of the water? Is there ample staging space around the area that's being dredged? And if not, where is that area? How accessible is the pond or lake to get equipment to? One of the things that I can say from personal experience, having lived on a 45-acre lake, is that, in our situation here, there's houses all along the shoreline. So the idea of bringing in heavy equipment and having a place to stage it in close proximity to the water is a substantial challenge. Other lakes that I'm super familiar with, like Candlewood Lake in Connecticut, which is like a 5,500-acre lake. In much of the lake, they have 70-foot tall cliffs leading down to the waterfronts from the homes with stairways and elevators and all kinds of crazy stuff. So, the idea of access is really important when you're looking at what kind of dredging is going to be done. And then finally, how easy is it to control the water level in the body of water you're looking to dredge? These items all contribute substantially to the cost of a dredging project. So dredging, there's really three types of dredging primarily. There's mechanical dredging, which is kind of the old school excavator in a pond, scooping out sediment, shovel by shovel, and putting it on the ground, and then that material drying and being loaded up into a truck and driven away. That's something that's still done and is still appropriate for certain types of dredging projects. Again, access is a big limiter, but beyond that, the other two technologies or the other two methodologies that we're going to talk about briefly are less effective in dealing with consolidated materials like dense sand or big chunky rock. Those kinds of things, are still best left to an excavator. In the picture you see there is one of the dredges that we've used, although not in a couple of years. We actually no longer have this dredge in our fleet, but that's an example of a horizontal auger dredge being operated with a pond being completely full of water. So mechanical dredging, I already explained. Hydraulic dredging is essentially a steel catamaran. A hydraulic dredge is a steel catamaran, or at least a horizontal auger hydraulic dredge is a steel catamaran with a boom that goes down and an auger head at the end. It agitates the sediment that's laying at the bottom of the lake and mixes it with water inside of a shroud. Right behind that is a big pump, and that pump is sucking what's called a slurry, that mixture of water and sediment, out through the pump, through the boom that is being used to lower the auger head, and then into a pipeline that carries all of the sediment suspended in the water back to shore. Similarly, diver-assisted suction dredging is essentially the same basic idea, except it's done by hand with divers who are supplied air from a topside air compressor, so they can go down and hand excavate sediment. So this is about mechanical dredging. It's really very effective on small bodies of water that are kind of self-contained. Any place where you have good access from around the perimeter of the pond, or even a lakefront, if there's access to get a machine down that's substantial enough to do the work that needs to be done, mechanical dredging is still a very viable option. From an environmental perspective, there are, of course, issues with this. In order to dredge like the pond in the picture that you see in front of you, we had to drain all of the water out of the pond, essentially killing pretty much everything in that environmental space within that pond, within that habitat. Other complications that come up with mechanical dredging, it tends to be an unsightly, messy kind of project with, you know, this loose organic sludge basically being placed on land and puddles of mud and things like that. You encounter odors. Um, Again, right tool for the right job, but in a pond setting like the one you see pictured, this could have easily been done using diver-assisted suction dredging without having to look at this entire mess. Going back to hydraulic dredging is super effective in moving soft and moderately compacted material. So that's going to encompass the vast bulk of the sediments most lakes have at the bottom in the Northeast. It's not absolutely true all the time. Sometimes you have heavy sand loads, um, and sometimes you can have clay, which is also more challenging to dredge with a hydraulic dredge. But even those two substances, those two types of sediment, can be dredged using a hydraulic dredge. It's just not nearly in doing so. From a cost perspective, hydraulic dredging tends to be very effective and very cost effective when you start getting up into the thousands of cubic yards of material. In the hundreds, I think you're probably better off looking at mechanical dredging or diver-assisted suction dredging. But when you get to a certain volume that justifies the cost of moving the equipment and placing the equipment in the lake and so on and so forth, and the setup that's required in connecting the pipeline and the geotextile tubes, it starts to become a more cost-effective option. It's good at preserving habitat, merely because you're not sucking all of the water that these organisms depend on out of a pond or a lake. So this is an example. The illustration is an example of what a small hydraulic, horizontal auger hydraulic dredge would look like if you were seeing a cross section of it working. So as I described earlier, at point number one, you have this turning auger bar, kind of like the front of a snowblower, and it's kind of chopping up the sediment and suspending it within a shroud and mixing it with water. The pump is right behind number one. It goes through the boom, denoted by number two, and then goes out the discharge line, which is floating hose or pipe, through number three. This slide is a slide on diver-assisted suction dredging. So in this particular case, if you're looking at the photograph, that little barge, which is about 6 feet wide by 11 feet long, houses a priming engine. That priming engine supplies water to a land-based pump that does most of the heavy lifting and provides the suction to the diver. In the upper part of the photo, you can see a couple of boat fenders or boat bumpers, little floats that are holding up a green hose that a diver is essentially guiding and using to suck material out of this pond. This pond is on the campus of a major medical equipment manufacturer, and they chose to do it this way because to bring an excavator in would have destroyed all the landscaping around the pond, would have been very disruptive to the people working in the office space next door, and would have caused traffic issues with all the trucks coming in and out, having to move that material for a prolonged period of time. Also, in the upper part of the photograph, you can see there's a turbidity curtain in front of their spillway. That's kind of a requirement of all dredging projects, but especially dredging projects where you're returning the water that you're taking out of the pond with the sediment back into the pond. Essentially, you create something called turbidity, which is suspended solids floating around in the water column. Most permitting agencies want to see you minimize the turbidity that you cause, both in the pond that you're in, but even more so in any downstream ponds. So, when you see one of those yellow booms going across the surface, sometimes it's just a boom trying to contain oil, if there's a spill or something like that. But sometimes it's actually a curtain. In this case, that drops down about 6 feet in the water column, which was enough to seal off that spillway while we were working. So diver-assisted suction dredging ends up being fairly cost effective when you count everything all in with landscape repair. It ends up being pretty cost competitive with mechanical dredging. But again, you're eliminating a lot of the headaches that go along with that. And also, it's going to be your most ecologically sensitive version of dredging. Um, having logged many hours underwater physically doing this myself, I can tell you that the mortality for animals within the pond outside of um, very small invertebrates is extraordinarily low. So this is like cross section of what diver assisted suction dredging actually is. So here we have the priming barge. We have a diver with a hose with a nozzle at the end, um, swimming up to a wall of organic sediment. And essentially, this was part of an animation that I showed at the last meeting that I attended with you guys. But essentially, the diver's taking chunks of that sediment, that organic muck, out of the water column and just kind of proceeding through. And it's kind of a game of underwater Pac-Man, if you will. Um, so I've mentioned dewatering a couple times. Dewatering from a mechanical dredging perspective is as simple as scooping up the material, turning the excavator around, placing it on land, somewhere for the water to run off and the sediment to dry. When we do it hydraulically or with diver-assisted suction dredging, we use what's called a geotextile tube. I'll have more details on that, but this is very typical of what the dewatering area on a given project might look like. So one of the requirements with a geotextile tube is that it's placed on flat land. And when I say flat, I mean very flat, because as you can see, these are tubes. And they can potentially roll and or shift with all that water in there, and sediment kind of moving around. If you want to try to picture like a water snake from when you were a child, a toy water snake, these things do like to shift. So having them on flat ground is very important. But then underneath the geotextile tubes is typically a liner. In this case, it's a 12 millimeter reinforced polyethylene liner. Essentially, sediment is pumped into the tube in that slurry that I mentioned before. And again, this applies to diver and hydraulic dredging. And the water can wick out through perforations in the tube, but it captures the solids and it holds the solids back. So when the water comes out, it comes into this kind of basin that we build around these tubes, and then the water is directed back into the lake or pond. One of the big advantages to, and I'm going to speak specifically to hydraulic dredging right now, is that, again, going back to my comments about my own lake and the limited access that exists in this lake and around the lake, you know, with hydraulic dredging, our larger hydraulic dredge, which is an 8 in, 8 out hydraulic dredge, that's the pump size input and the pump size output, we can actually transport sediment in the slurry up to 1,500 linear feet before we have to repeat the pressure in the line. So, if we had to go further, probably around 1,000 feet, we would put a booster pump in line in that pipeline. But by doing that, you can effectively transport the sediment almost limitlessly. You just have to add more pumps. The downside to doing that is it gets progressively more expensive to do so. But we've pumped material the better part of a mile to find an open space that doesn't need as much preparation to get rid of the material and to allow it a place to dewater. Obviously more complicated if the requirement is to send the water back to a lake or pond. However, again, almost anything can be done, and it has been. Other things that you're going to want to think about if you're ever planning a dredging project and you're utilizing hydraulic dredging, really any kind of dredging, is what are you doing with the material at the end? When it's all dried out, where does this material go? And the material is going to go to one of three places. The first place, the most simple and the easiest to permit, generally speaking, is it's not going anywhere. Exactly where it's pumped or where it's excavated, it's basically essentially smoothed out and mixed in with existing soil. It's seeded, raked, seeded, and hayed. Once the site is stabilized, you're returning that area to lawn or to meadow or to whatever it was before you started using that space. So that's option one. Option two is that it's trucked off-site. And 2A on that is the first possibility is it's trucked out to a landscaping yard or a materials yard that will turn around and reuse the material by mixing it with sand and potentially topsoil, as well as a number of other additives to turn it into high-grade organic topsoil. So that's done pretty regularly on clean sediments. Second possibility is the sediment is contaminated, non-toxic, meaning that it's above the EPA guideline on residential soil limits when it comes back from testing for some impurity. Typically, these impurities are either heavy metals, so think like copper, or arsenic, or potentially it's tainted with non-volatile organic compounds, which are chemicals that come from all kinds of things, but most closely associated, I would say, with the production of and use of asphalt, tar, things like that. Roads do a number on our ponds and lakes, and the care that we take with them today, while still not perfect, is far, far better than it was 30 years ago, or 40 years ago, or 50 years ago. So it is possible to find these things in our bodies of water. In those cases, if it's above the EPA level for residential soil use, which is published online through the EPA website, two things can happen. It can be taken to a contractor's yard like we discussed before, and it can be amended, meaning that it's mixed with additional clean material to dilute the concentration of that impurity that was above that EPA limit. Or the third option, and rarely done unless it's, closer to being toxic, is that it goes off to an incineration plant or a landfill. The third or fourth possibility is that the material comes back tested and is highly toxic. So the level of contamination is far beyond the EPA soil limit to a point where the only way to deal with this material is to actually burn it. So that's what happens to sediment when it leaves a dredge site. I would say probably 50% of the time, the material is reused on site in a beneficial way. 40% of the time, or even 45% of the time, the material is taken off-site to a landscaper's yard, and repurposed and then resold. And then the last possibility, the incineration or landfill scenario, is exactly that. So, I would even say less than 5%, but it does happen, especially when you have Superfund sites and a lot of industrial processes. So these tubes, just to give you perspective, are approximately 30 feet wide by 120 feet long. So that tube, when it's fully pumped up, can hold the equivalent of approximately 1,000 dry consolidated cubic yards of sediment. And that translates to probably more like 1,500 cubic yards of wet in situ sediment. In situ refers to the volume the sediment takes up in the column when it's fully submerged as it's found. The tubes can be sized in custom sizes, set surfaces or widths. This is a detail of what the cross section of that dewatering plant that we were just looking at basically looks like. Essentially, we raise the edges around these tubes to create a berm, but think of it as like a small above ground swimming pool, temporary above ground swimming pool that we place the tube in. So when we pump the material and the water, the slurry, into the tube, as it settles and the solids go to the bottom and the water stays above that, it has the opportunity to kind of leak out through the perforations in the weave of the geotextile fabric. It'll filter down particles to about 100 microns, and then after that, you're talking about super fine particles, which will be pumped back into the lake and or pond as part of that return water. The reaccumulation from a volumetric perspective is nominal on superfines. However, you do have that turbid water. For that, they make chemicals that can settle those superfines in the tubes to release cleaner water. You can get it down to potable water using the right flocculants, which again are these chemicals, which are in some cases safe, very safe. In other cases, less safe, and in the last case scenario, not really safe to be drinking. But those are rarely used. So you see, in most cases, we use hay bales or an earthen berm. We drape the liner over that to create that, and then the water is directed back. So that's my little presentation on dredging, but really focused in on the hydraulic and the diver-assisted suction. If anybody has any questions, I'm happy to answer them now, or my contact information is included in the presentation.
I see the last question. Hey, Mark, can you hear us?
I sure can.
Okay. I'll repeat it to him.
Using those tubes that he was just describing, how long does it take for the dewatering process?
So Mark, we were wondering how long it takes a tube to dewater.
Sure. So the first thing is you have to think about the fact that it's constantly dewatering during the pumping process. But there's two types of dewatering. There's the ancillary pump water that is used as transport media to carry the solids in the pipeline. Excuse me. That dewaters pretty rapidly. The moisture within the organic material takes a bit longer to dry out and get out of the tube. That material and that water dries at a fairly reasonable rate. However, it depends on the ambient environmental conditions that it's in. So if you, let's say you do a dredging project in the spring, and you start, let's say, late March, early April, after the thaw. Excuse me. So the temperatures, the nighttime temperatures still rather cool at that time of year, and the daytime temperatures, obviously vary year to year. But if you assume you're getting 60 degrees, and you're assuming 50% of the days are cloudy and 50% of them and rainy, and 50% of them are sunny, I would estimate, dependent on the material, that's actually what the composition of the material is, you're probably talking somewhere between 6 and 10 weeks for that material to completely dry out to the point where it can be moved. If you start in, let's say, May and complete the actual physical dredging by some point in June, I would anticipate that drying time, again, material and weather dependent, to go down to somewhere between 4 and 6 weeks. So longer days, more sunshine, hotter temperatures are generally the key components in determining the dewatering time for the sediment once dredging is complete. Hopefully that answers your question.
Thank you.
Yep.
And those big tubes, it says that solids go in and only like the liquid can get out of the small things. How many like turtles, frogs? Unfortunately, it's wrong.
Sure. So,
Got it.
right. So you're asking about mortality. So nothing that goes into the pipeline in dredging other than water gets out of that geotextile tube. That said, again, as somebody who's done literally hundreds of dredging jobs, whether they be diver assisted or hydraulic, and even some mechanical, my comment would be that when we're doing the diver dredging, the only animal that we've ever seen that we think has any substantial mortality rate, meaning it somehow ends up in the tube, would be frogs. The reason I say that is when we're doing diver, and again, I'm going back to diver because I apply the same logic for why they avoid us in hydraulic to why they avoid us in diver to hydraulic. There's a bigger animal in the pond right next to it. So fish, snakes, turtles, they tend to move away from us. It's kind of a flee response. In addition to that, we have engines running that create vibrations in the water, which also causes animals to kind of scatter and move away from us. So in probably close to 100 diver dredge jobs alone that I've personally done with others, I would say that I've had 3 encounters with snapping turtles, okay, where a snapping turtle did not move away from me to get away from what I was doing. Not that we could ever suck up a snapping turtle with a 4-inch line, but my point is that most of these animals get away from us, and we can see the animals while we're working to some extent. Fish tend to keep their distance. As I mentioned before, the poor frog is the only animal in the pond that has literally zero survival skill and survival instinct. In our experience, I could be right in front of a frog, staring it in the eyes from 3 inches away, kind of splashing around, and the thing will just sit there. The frog won't move. So, that's the only animal that I really ever am concerned about when we're working on a diver level. Everything else makes itself scarce, goes to a different part of the pond than where we're working. But I believe the same thing is true for hydraulic dredging, and they have done a couple of studies on mortality in hydraulic dredging, which are published online. Simple Google search and you'll see what they have to say. However, it's usually estimated to be quite low. And the reason why is exactly what I said before. There's this big foreign object moving around in the pond and working where they are, so they move. And the rumbling from a hydraulic dredge underwater while that's being operated is substantial. To my knowledge, I've never seen any animals that we've harmed doing hydraulic dredging. Of course, we wouldn't necessarily see it if we did. So again, my belief is, and we take whatever precautions we can to try to limit that, but most animals, again, have that survival instinct and flee. So that's the best answer I have for you.
Mark, I have a question.
Sure.
So you were saying, you talked about the 3 different types of dredging, and if 50% of the material, in most cases stays on site.
Yeah.
And you also mentioned that there are pros and cons to, the area around where the dredging is taking place, specifically the shoreline.
Mm-hmm.
So, excavators and stuff are going to put big piles of dirt on the shoreline, which has to be fixed later on.
Yes.
But these giant tubes that are laying on the property with big tarps underneath them and, berms and all that. First of all, how does that stuff ultimately leave if it needs to? And how does that not do the same level of damage, if not more, to the property versus an excavator on a regular track into the lake and just stacking it up in one location?
Sure. So I don't really consider the material being deposited on the shoreline as being something that actually damages the waterfront per se. That's a temporary minor cleanup and damage at the end. What I'm thinking about more is when you're talking about a long stretch of shoreline, if you're not coffering the area that the excavator drives and the excavator actually drives into the lake, if they're working from shoreline and they're driving a long reach excavator in most cases back and forth over the same land, and even a low pressure long reach excavator exerts tremendous pressure on the ground. So what I'm really referring to is what driving an excavator back and forth on a waterfront property near the water where it's especially wet is going to do to the land. That doesn't even get into the kind of problems you can have if you put something of that sort of weight on the land and its effect on like bulkheads and stone walls and waterfronts that are less natural and more manicured. Doesn't get into the idea of what people do to landscape around those areas. Your point regarding the geotextile tubes as the alternative, well, that's a valid point. When the geotextile tubes are completely dry, essentially they're one-time use. Nobody's invented one that can be reused with like a zipper in it or anything like that. I guess the pressure on it is too great. But essentially they're cut open and then excavators, front loaders and excavators loaded into triaxle trucks that need to drive away. But again, that's part of the whole entire planning process of how you're going to do the dredge. If you can find the right locations to house these geotextile tubes, that doesn't have to be nearly the kind of destructive inconvenience that an excavator, traipsing across the shoreline of a pond or lake ends up being. Generally speaking, all dredging essentially ends up being approximately the same in terms of cost. If you price out hydraulic dredging versus mechanical dredging, most of the time they're pretty close. The difference is that more of your cost in a mechanical dredging project is specifically geared around landscaping repair. Whereas, you know, again, if a hydraulic dredging project is planned correctly, that part of the expense is not, that does not, it doesn't overwhelm the cost. They basically come out the same because of the repair expense on mechanical dredging and what it does to the land where they're driving. That's the simplest answer to that question.
Okay.
Yep.
Anybody else? Because I have one more. Go ahead.
So Mark, in New Jersey, does the DEP have different categories and terminology for dredging and some lenient than others?
So, my understanding is no. All state agencies essentially report back to the Army Corps of Engineers and to the EPA's guidelines. And the EPA's Clean Water Act is the overarching rule that's generally used for guidance. And that guidance says that every time you are filling or removing material from a wetland environment, you were in violation of that act, right? What they define as wetlands is well, first off, what you think of immediately when you hear the word wetland, which is, you know, kind of a marshy kind of transition between land and a body of water, typically in riparian zones, or the littoral zone around a lake or a pond, and then the setback beyond that. But they also define lakes and ponds and rivers and streams and brooks also as wetland environments. So all dredging needs to be permitted from my perspective and in my while we're environmentally less invasive than, say, an excavator doing mechanical dredging, there is still an invasive component, and the permitting bodies, permitting agencies want to have oversight in terms of what's happening in the freshwater water supply. So, and in the ecosystems. So the quick answer is you don't get any permitting shortcuts by doing your dredging hydraulically or diver assisted. What you do get is you get a lot more consideration because of the lesser environmental impact. So typically permitting for these projects utilizing these two methodologies, I'm not going to say is simpler, but it's more well received. That's the best answer I have for that question.
For hydraulic dredging, if we were to do it in an area, say 300 yards out from a beach that had a parking lot adjacent to the beach, that'd be a good dewatering spot, opposed to, because then the material would have to be moved from there to an area that it would be spread into a field.
Right.
Well, better when possible to run that tube, say 2.5, 3 blocks up the stream to where the field is, and have it dewater on the site where it would be spreaded and used permanently.
Absolutely. From a cost perspective, that is one of the big advantages of hydraulic dredging over mechanical dredging. You just cut out whatever distance that is in trucking and handling. So generally speaking, the way excavation sites work and mechanical dredge sites work in particular, the more times material needs to be touched, the more expensive it gets. So, you know, even when you think about a mechanical dredge site, and I don't know if everybody there or anybody there has seen a mechanical dredge site being, you know, project being executed, but what I said before about a long reach excavator, long reach excavators are built to reach out and grab and drag sediment back to shore. They're actually not built or intended to scoop and lift sediment. Because of that reach, it just that's they're not engineered for that, right? So what ends up happening is you end up having the long reach excavator dragging that material back to shore. Then typically a smaller, lower center of gravity and shorter boom excavator turns around, picks it up, and moves it, right? And then finally, you end up with typically some sort of loader or something loading it into the trucks directly. So it's not, so again, the more pieces of equipment, the more handling of the material that you have, the more expensive and convoluted the project gets. So with a hydraulic dredge, that big advantage is that sometimes you need a piece of equipment to actually pick the dredge up and place it in the water. Sometimes it can be loaded off of a trailer on a boat ramp. So in those scenarios, you're talking about a truck making 4 trips across the land, one in, or 2 trips, 4 trips, one in and one out to drop it in the water, then one in and one out to take it out of the water. You're not running trucks all over the place, and you're not having to move material after it's dried in a staging area to that final deposition site. So if you have that kind of setup, hydraulic dredging is a good choice for you, because once it goes into the dredge, it ends up in the geotextile tube, and it doesn't stop until it gets to, well, it doesn't, it basically stays there the rest of its life, is the idea. So.
Does it work around rocks? You have a lot of rocks in the lake bed.
So to some greater or lesser extent, yes. But obviously you're talking about a rigid machine, right? In situations where there's a lot of boulders or heavy rocks, it'll shave sediment down until it hits those rocks, and then simply creep and crawl over those rocks. But it can't get, super close and hit all the contours in between rocks, nor can it, move those rocks.
Right, but it wouldn't prevent using,
I'm sorry, what was that?
would not prevent using hydraulic dredging if you
No.
did on base. Okay.
You just have to assume that those areas are either not being dredged or they're being dredged with an alternative methodology. In this case, because you have a hydraulic dredge doing it, and you can simply take off that auger head and attach a suction hose to the pump. If there was a large area that needed to be dredged in between and around these boulders, say, you can send a diver in to do the diver assisted, and then he can get everything. He or she can go in there and has the ability to maneuver the hose into place to suck that material out. So that's how you kind of get around that. But to that point, mechanical excavation has the same downside. You're only going to get so close with a bucket unless you're moving the boulder. So.
Yes,
I have 2 questions. One is, how hard is it to get a DEP permit? How long does that take? How much does it cost? And then also, we're trying to figure out if we should be doing hydro raking or dredging.
Mm-hmm.
I wanted to know your thoughts on that.
Sure.
hang on a second, Mark. We're actually going to do a presentation on how to go about that permitting process.
Mhm.
We're looking at either the October meeting or in the spring.
Okay.
So, but you could, Mark, just kind of tailor that and answer a question.
Sure. So first off, I have handled permitting directly. I no longer do so because I outsource that function to somebody and to professionals that are far more efficient in doing it and deal with the people that they're interacting with on a more regular basis. So take what I say as take it with a grain of salt, in that I've never directly permitted a project in New Jersey. I have in Connecticut, I have in New York, and I have in Massachusetts, but I haven't done so in New Jersey because, again, I've used other people to do that for me. That said, most of these agencies operate pretty much the same way. Although permitting in different states is different. I would say New Jersey is more analogous to New York than it is to Connecticut, and maybe more analogous to Massachusetts and Connecticut. Connecticut tends to be unique. basically our version of DEP, which is what you guys are under, is referred to as DEEP. And here they actually push all of that permitting work and the jurisdiction for inland waters in non-navigable waterways down to the town level and let local inland wetland boards make those decisions. In New York, almost everything runs through a town layer and then the state layer, right? So it goes to the DEC, which is your DEP for all intent and purposes. And by the way, you guys even have another potential unique quality, or we've interacted with it, is that you also have parks. You have a very, I don't know what the right word is, but you have a parks department that also handles some of that permitting at the state level, separate of your DEC, or your DEP, I believe. I ran into that once in Jersey, but it wasn't on a project that actually was executed. It was planned, and then for a variety of reasons, the project was not completed or initiated. In any event, the process, generally speaking, pretty much everywhere, except for Connecticut, I'll tell people, is anywhere from 3 to 12 months to get a permit on dredging. A lot of that has to do with the materials that you've prepared and the materials you need to have to satisfy the permit requirements. In some cases, depending on again where it's being done, you're going to need to show a full site plan for the dredging operation. You're going to need to show land surveys, updated land surveys for any on-land activities. So in the dewatering portion of hydraulic or diver dredging, you have that. In the mechanical portion, you also have that. You need to show your dewatering area, your final spoils deposition site, if that's what's happening on property. Generally speaking, those surveys need to have wetland delineations shot in the survey that show the wetland buffer and the actual wetlands. Those are usually completed by environmental engineering firms and or wetland scientists that do either soil sampling or just identify based on plant life. So, having those things ready before you go into the permitting process will substantially change the length of time it takes to get through permitting. Is that somebody asking a question or?
No.
Okay. So in addition to that, in many cases, you'll need what's called a biological narrative. Again, those can be completed by most science professionals. I'll say wetland scientists, environmental engineers, biologists, limnologists, aquatic biologists. These are all generally, if they have experience in this field, they could come from many different walks of life or many different professions, but they can complete those biological narratives, which essentially describe the flora and fauna within the work zone and the greater area, and describe it environmentally. All these things kind of go into these permitting applications and presentations. Almost all permitting in some way or another somehow reports that activity back to a general permit under the Army Corps of Engineers federally, again, to make sure that everybody stays in compliance with that EPA Clean Water Act. The only thing I'll say about that is it's rare on anything but the largest inland waters projects for Army Corps to get involved. So they'll get involved in the Great Lakes, they'll get involved in the Finger Lakes, they'll get involved in the Hudson River or the Potomac River, or the lakes down in Louisiana, coastal regions, things like that. However, Most of the smaller projects out there, the state agency essentially, the state agency or the permitting professional will submit a letter of intent to the Army Corps of Engineers, and then they have a period of time in which they can reply and say if they want to get involved, if they are interested in the project in such a way that they feel they need to have a full permit application. It used to be before the pandemic that there was a 90-day response period, that they essentially had 90 days to respond to that letter of intent. And after 90 days, the instructions were to assume that they're not exercising any jurisdiction over the project. During the pandemic and since the pandemic ended, that number was cut down to 45 days. I can tell you that in, all the dredging projects that we've done over the last 10 years, maybe 2 of them, we got an actual email response on. And both of them were very simple and quick questions that were answered, and then they went dark again, and the assumption was that the Army Corps of Engineers did not care. The state agencies are going to have a little bit more to say about it. Generally speaking, if you have your materials assembled, I assume cost to do permitting, which usually is tied into developing the site plan and everything else. Again, depending on the size of the project, I usually consider it to be something between $10,000 and $30,000 unless extensive engineering is involved and other improvements are being made to stormwater systems. So, think like steam bank reinforcement or stream bank reinforcement with like gabions or bouldering or deceleration pool sediment in streams as they open into a lake. All good things to consider, but they do add a layer of complexity and cost to the site plan, the planning, and the permit. So hopefully that answered your questions.
Hydro raking?
I'm sorry?
Hydro raking?
Oh, yes, hydro raking. So typically hydro raking is an easier permit to get. It's considered to be less invasive. Now, I want to be very clear about this. There's hydro raking, which is, probably what you're referring to, which is essentially it's a mini excavator on 2 pontoons, right, with paddle wheels for propulsion. I believe you have a company down in New Jersey that's one of the few companies that actually owns and operates a hydro rake in the Northeast. I think Princeton Hydro has one, maybe not, though. Maybe I'm thinking of somebody else. In any event, that's using a rake head, okay? And the goal with hydro raking is to remove plant matter, preferably plant matter that doesn't reproduce through fragmentation, like milfoil or curly-leaf pondweed. But hydro rakes are effective at removing vegetation, and they're very effective at debris removal. So sticks, leaves that aren't fully broken down into muck. That's what real hydro raking is. A lot of hydro raking companies, and this isn't an indictment of anybody really. It's just, kind of working within the system and the set of rules that are established. A lot of hydro raking projects are essentially wet dredging projects where a rake is being removed from the end of the machine and what looks like a front loader shovel is being placed on it. That is a way to circumvent the heavier permitting. But for all intended purposes, you are dredging at that point. You are removing fill and sediment, whether it's organic or sand. It's an effective process to a degree. It is not nearly as comprehensive, and it's certainly not capable of removing the volumes of sediment that hydraulic dredging is geared for. And then I say that, and at the same time I say, okay, so how far down can a hydro rake remove material from? Probably about 5 feet, I believe. I think that's correct. So in a shallow water scenario, it can be effective, but it's not. With both of our hydraulic dredges, we can dredge down to between 15 and 20 feet from the surface of the water. It's also much more meticulous, meaning that you get more of the actual sediment. Again, when you're wet dredging, which is not well looked upon, generally speaking, clamshell dredging and wet scooping, that's typically something that's left for marine applications at this point. Inland dredging, you're always sensitive to that turbidity issue. And when you're hydro raking, you are letting a lot of the material and the water that comes up with the material mix and then go back into the body of water while you're doing the work. There's no way to eliminate that. And that creates turbidity. Turbidity is generally considered bad because it can impede organisms' ability to breathe. But in addition to that, you're also suspending and freeing nutrients from the organic sediment at the bottom of the lake or pond that you're trying to remove. That can lead to algae issues, and dovetailing into the conversation you guys were having earlier, worse than algae, you can end up with bacterial issues. So you get into your cyanobacterias. Hydro raking is really not a replacement for true dredging, but it's certainly an effective way of dealing with certain problems, and can do some things similar to dredging. Again, best answer I got.
Excuse me, I've been told that after dredging, there's a good, if you already have a cyanobacteria issue, that the dredging is not going to necessarily stop it, and sometimes it will trigger a bloom after the dredge. Would you say that's a fair statement?
I would say that it's partially fair. So again, anytime you suspend sediments, organic sediments in the water column, and you make phosphorus, usually it's phosphorus, but I guess nitrogen too to some lesser extent, you make phosphorus available for cyanobacteria, and then you're going to feed into the problem. So to some extent, I agree with that statement that dredging can exacerbate that. I think that whenever you're looking at a nutrient loading issue, such as cyanobacteria dominance, right? You have to look at a number of different factors. Dredging is one of the best ways, and really the best real permanent solution, semi-permanent solution to addressing point source nutrients. Now, dredging does absolutely nothing to impact non-point sources. That said, where do I think the bulk of cyanobacteria production comes from a nutrient level? I think the bulk of it comes from non-point sources. I think the stormwater that comes into your ponds and lakes is more of a culprit for causing bacterial growth and providing available nutrients to that organism than point source nutrients do in the first place. So, the question is a good question, but there's nothing that replaces resetting the habitat to its original condition. Dredging is sometimes and often more often, it's going to happen more often in the future, the one of the only real solutions you have to those issues. Because even in absence of the non-point nutrient sources, you are going to have point source point source nutrient issues from the sediment that resides on the bottom of a lake. The only other thing you can do to eliminate that is start looking at your flocculant treatments. So think like alum and Foslock and whatever other brands are being marketed these days. But those are temporary solutions, and gradually, slowly but surely, as you're flocking that point source nutrient bank, you're also reducing depth in your lake and pond, which means that the temperatures in that water column and thus the dissolved oxygen levels are going to continue to go down over time. So I think dredging has its place in your arsenal of tools, just like everything else does. I don't think it's a silver bullet for managing cyanobacteria issues, but I think it's one of the weapons in your arsenal. I don't know. Is that a reasonable answer?
Thank you.
This is gonna be your last question, Mark, because we gotta. So, go ahead.
Real quick, best times over here to do the different methods. Dredging?
I'm sorry, Tom, could you restate that, or whoever is sitting next to the.
Best time of year to do any of the dredging types.
Okay, yeah, that's fantastic. So generally speaking, it really depends on the scenario, but early spring is a good time to dredge, before spawning season has really begun, in the ponds and lakes. And it still gives you an opportunity to get that quicker drying time, and dewatering time for the sediment that comes out. Early fall is also acceptable, although, if the dredging project goes on long enough and you stretch into overnight freeze temperatures, the moisture in the tubes can freeze up, and then you're waiting until the next spring, basically, to remove that material offsite to get rid of the spoils. Summer is actually fine, as long as there aren't other complicating issues. So what I mean by that, kind of goes back to that last conversation we had. The last thing you would want to do, and the last thing we would want to do, is in a situation where you have low rainfall totals, hot temperatures, lots of sunlight hitting that water, suspend a whole lot of nutrients in the water column, which happens when you're doing dredging of any kind, right? So it's all based on the scenario. How big's the pond? What kind of vegetative bank does it have in the pond? What's the ability of the pond to filter nutrients currently? One of your biggest aids and weapons, I guess, in dealing with cyanobacteria and nutrient loading in general, is having good stock of native healthy plants that filter that water for you. So the best times are early spring and early fall, but even summer is perfectly fine if it's being done correctly, and somebody is thinking about all of these things ahead of time and taking precautionary steps to ensure that it doesn't go down in a different direction that you don't want it to go. Winter is good for mechanical dredging. It is not the ideal time for hydraulic or diver, just based on water temperature and ice. So